Okay, so the quotient rule here we're going to be using, right? And it's quotient because you've got two functions which are dividing by each other, okay? Quotient just means divide, right? A division. And we've got a function on the top and a function on the bottom, right? And the numerator and on the denominator, okay? And you can't just take this up, right, and put it to the -1, right? Because it gets really messy if you do that, right? So you've got what is called the quotient rule, which helps us when you've got a function on the top and bottom. So we're going to call the top function u, okay, which is going to be 3x squared plus 2, and the bottom function is called v, right? So it's important you have it in that order, right? U on the top, v on the bottom. So you do then du dx, just like with the product rule, so you get 6x, and dv dx, and you just get 2x there, right? And then with the quotient rule, it's different to the product rule, but you're still doing the v du dx, okay, and u dv dx, but there's a minus in between them, right? So that's important. And also as well, you've got to divide by v squared, right? That's what the quotient rule is. So crisscross, that times that, okay, so that times that, maybe I'll put the 6x at the start, okay, doesn't matter, right? That times that, 6x first, all right, so it's easier to multiply. Take away then u dv dx, so that times that. So again, I'll put the 2x at the start. All over v squared. Now, v is this, isn't it? Okay, and I need to square it. So I've got to put it in a bracket to show I'm squaring it. Right, that's what it is, isn't it? V squared, so the whole thing's squared. Now, it comes to simplified, right? And you need to simplify here. Word of warning, do not, whatever you do anything to this, right? Just leave it as it is. Don't expand it, because you're making it harder. You're making it less simple by expanding it. So leave that as it is. It's as nice as it can be. The top, obviously, we can sort that out, can't we? We can make that a bit smaller, simplified down. So, as I said, let's leave the bottom. Let's even write it now to start with. Okay, that's not changing. Now the top, multiply out the brackets, yeah? So 6x times that's 6x cubed. 6x times 5 is 30x. Multiply through here, 2x times 3x squared is and it's minus, isn't it? So it'll be minus 6x squared. And then 2x times 2 is 4x, but it's minus 2x times 2, so it's minus 4x. And that's it. Oh, that should be cubed, shouldn't I? I made a little mistake there. 2x times 3x squared is 6x cubed, isn't it? And I'm done, more or less. Now, we've got this here, though, which can be simplified, of course, on the top. That's why I expanded the bracket. 6x cubes will cancel, won't they? That take away that goes. And you end up having then 30x take away 4x is 26x, yeah, over this on the bottom. And isn't that much nicer than expanding out the bottom? Okay, so that's it. That's simplified, right? That's how they'd expect us to do it. If they give us something like this involving other functions, so suppose I've got this y equals ln x over x squared, you go through the same process. You appreciate it's a quotient. U on the top is ln x, v on the bottom is x squared, and you do du dx, and you do dv dx. Okay, right? You work them both out. Right? It is a quotient though. It's a u over v. Okay, remember u is on the top, v is on the bottom. So ln x becomes 1 over x, dv dx becomes 2x. Using the quotient rule then, dy dx equals, okay, remember now, you've got to use that long one, v du dx, but it's a minus u dv dx all over v squared. So v du dx, that times that, right? That times that, so x squared times 1 over x. Take away this times this, okay? So 2x times ln x all over v squared. Now, v squared is already x squared, but you're asked to square it again, yeah? Okay, so what happens then in the next line? Well, x squared times 1 over x, they cancel and it just becomes x. Take away 2x ln x. The bottom, you can tidy this up a bit, you know, you don't have to leave it like this now, because when you've got one power raised to another, you can times them, so you get x power 4. And on the top then, right, on the top you notice here, we've got common factors, haven't we, of x. X goes into both. So we can take out x, you can factorize x, bracket, x times 1 gives me x, and x times 2 ln x, or minus 2 ln x gives me that. So factorize on the bottom, x power 4. And we can even tidy this up further, because x on the top, x power 4 on the bottom, that will cancel with that power and make that a 3. So I end up having 1 minus 2 ln x over x cubed. Okay, let's do one more like that, where we've got, for instance, trig functions involved. So suppose I've got y equals, I don't know, 2 plus cos x over, say, 1 plus sine x. Okay, so we could have something like that. Well, there's no harm, you just realise now it is a quotient rule, so u equals 2 plus cos x, v equals 1 plus sine x. So du dx is equal to minus sine x. Differentiate that, yeah, because 2 becomes 0, cos x becomes minus sine x. dv dx, sine x becomes cos x. Is that right? Good stuff. So, quotient rule. Okay, dy dx, v du dx, take away u, dv dx, all over v squared. So, it'll be that times this. Okay, so it'll be that times that, so we'll have minus sine x. Take away then u dv dx, that times that. All over v squared. Now v is this, so you've got to square it. So you get minus sine x times 1 is minus sine x. Minus sine x times sine x is sine x squared, or sine squared x, yeah? That's how you say it. Sine x all squared is sine squared x. And then times through the bracket by cos x, you get minus 2 cos x, and then minus cos squared x here. Okay? All over 1 plus sine x all squared. And then what you do then is you've got loads of minuses at the top here, and everything's minus. We could just take out the minus as a factor. Okay, minus 1, yeah, and bracket. So everything becomes positive then. Sine x plus 2 cos x. And I'll write this in a certain way. And you realise then you've got sine squared x plus cos squared x, which of course is 1, isn't it? Now don't forget this here, you don't expand, and we left with our final answer, minus 1 in bracket sine x plus 2 cos x plus 1 all over 1 plus 2, 1 plus, sorry, sine x all squared.